Okay, so now to section 10.5. After doing quadratic functions in 10.4, we're going to do quadratic and other nonlinear inequalities. But first, let's discuss quadratic inequalities. So let's see the transition, what we did in 10.1, 10.2 about quadratic equations to quadratic inequalities. Quadratic equations in 10.1 and 2 to quadratic inequalities. 10.5. So the general form of a quadratic equation was ax squared plus bx plus c equals 0, and we learned several methods: factoring, square rooting, completing the square, and the quadratic formula. So to solve something like x squared minus 6x equals 7, the first thing we had to do is set it equal 0 if we were going to factor. It's factorable, factor. If not, use the quadratic formula. So x minus 7 equals 0, x plus 1 equals 0. So we get two solutions, 7 and negative 1. So once we go to quadratic inequality, we're not going to have an equal sign. We're going to have a less than, greater than, less than, or greater or equal to 0. Okay? And to solve something like x squared minus 6x, say, is greater or equal to 7, the first thing we want to do is set it equal 0. And we're going to solve the quadratic equation. Solve the equation x squared minus 6x minus 7 equals 0, which we already got these values. These are called critical values. And what do we do with those critical values? Because remember, we basically want minus 7 times x plus 1 to be greater or equal to 0. So it could be positive times positive or negative times negative. So in order to avoid all these complications, we plot these points on the number line to create intervals. The interval from negative infinity to negative 1, including negative 1, using a bracket because it says greater or equal. So we're going to use bracket when it's greater or equal or less or equal. And we're going to use parentheses just like open circle and closed circle. Okay, and then the interval from negative 1 to 7, and then the interval from 7 to infinity. 3 intervals, 1, 2, 3. 2 test point or 2 critical values, 3 intervals. Then we're going to check one value from within each interval to see if it's a solution or not a solution. If one value is a solution, then the whole the whole interval is a solution. So if you pick negative 2 in interval 1, I'm going to enter the original one. Negative 2 is greater or equal to 7. 4 plus 12, it is true. So the whole first interval is true. If you pick 0 from within the second, 0 minus 0 is greater, it's false. So this is false. And then the third one, if you pick it, it's true. So your solution intervals are negative infinity to negative 1. So you can see we went from solution or 2 solutions to infinitely many solutions. Do we have steps to follow? Of course we do. And I have the steps written on page 44. I also have a handout included in the notes of this. You write the equation in standard or general form. You solve the quadratic equation just like we did by factoring. If it doesn't factor, then you need to do the quadratic formula. Use the critical points to mark off test intervals. Pick a test value within each interval. If the test value is a solution of the original equality, then the whole interval is a solution. Otherwise, the whole interval is not a solution. And then you always want to write your solution set to the limitation. Okay. Number 16, page 884. Page 884, number 16. Solve the inequality x squared plus 2x minus 8 less than 0. So we start out by finding what we call critical values. X squared plus 2x minus 8 equals 0. Luckily, this factors plus 4 minus 2. So the two critical numbers that we're going to put on the number line are negative 4 and 2. And then the two values will divide the number line into 3 intervals. It's always one more interval than the number of critical values, always. From negative infinity to 4, now we're going to use parentheses because negative 4 is not a solution because it's less than. And then negative 4 to the second test point, and then, critical value, and then the critical value of 2 to infinity. 1, 2, 3. Now, you can assume that the test intervals alternate. By alternate, I mean it could be true, false, true, or false, true, false. Okay? As long as none of the critical values appear an even number of times. Like each critical value appear once, one time is odd. If x equal negative 4 appears twice, like if you have x plus 4, then you cannot assume that. Okay, so as long as each critical value appears one time or 3 times, which is not going to happen when it's quadratic, but it's higher degree than you could have 3 times. So as long as each one of these show up one time, then you can do alternating method. If any of these show up twice, then you cannot assume they alternate. And the reason for this is because now we can check 0, which is in 2. Is 0 a solution? You always check it back in the inequality, okay? Negative 8 is less than 0, true. If this is true, then that's false, and that's false. Remember, they alternate, which means negative 4, 2 have all the solutions. Here's another one, 22, page 884. X squared minus 8x is less or equal to negative 15. So set it equal 0 by adding the 15. To find the critical values, we solve the quadratic equation. X squared minus 8x plus 15 equals 0. A product of 15 and a sum of negative 8, negative 5, and negative 3. So the critical values are 5 and 3. We're going to plot those values on the number line. Since each one of them appears one time, we can assume the solution intervals will alternate. The first interval is going to start at negative infinity and end at 3, including 3, then at 3, and then ends at 5, then starts at 5, all the way to infinity. And since each one of these appear an odd number of times, we're gonna assume they alternate. We put a 0 in there. 0 squared minus 8 times 0 is less or equal to negative 15, which is false. If 1 is false, then 2 is true, and that's false. 2 is the interval from 3 to 5, and this has all solutions. Okay, number 50, page 885. 50, page 885. X squared is greater or equal to 16. So it's x squared minus 16 is greater or equal to 0. To find the critical values, x squared minus 16 equals 0. This is the difference of two squares, x minus 4 times x plus 4. So we get 4 and negative 4. Again, each one of them show up an odd number of times, so we can assume the solution intervals will alternate. 1, 2, 3, 4. 1, 2, 3, negative 4. So we have the interval from negative infinity to negative 4, including negative 4 to 4, and then 4 to infinity. Again, I'm using brackets because it says greater or equal. Okay, 1, 2, 3. I'm always going to pick 0 as long as 0 is not a critical value. 0 squared is greater or equal to 16. False. That means true, true. So true, negative infinity to negative 4, including negative 4, union 4 to infinity, including 4. Okay. So here's an example where I'm going to show you that the solution intervals do not alternate. How do we solve the inequality? x squared minus 8x plus 16 is greater than 0. So to find the critical values, we set it equal 0 to solve the quadratic equation. Product of 16 and sum of negative 8 to x minus 4, x minus 4. So you can see we got the 4 twice, which makes it an even number of times, which tells me that the solution intervals will not alternate. There's only one critical value, so there's going to be two intervals, one from negative infinity to 4, and then one from 4 to infinity, and these will not alternate. So if you pick 0 and you check it, 16 is greater than 0, true. If you pick 5, which is greater than 4, check it, 5 squared minus 8 is 5 plus 16, that's 25, 41 minus 40 is 1, which is also true. So you can see it's true. My solution interval is negative infinity, so it's all real numbers except 4, basically, right? 4 to infinity. All real numbers except 4. Okay, so this takes care of the first half of the section 10.5. The second half is rational inequalities. Now, and so we're going to have an inequality, and rational means you're going to have something like P over Q is less than 0 or greater than 0 or less or equal. This is a polynomial and this is a polynomial. So if you divide two polynomials and make it less than or greater than 0, you get what we call a rational inequality, and this is called the standard general form. Standard or general form, meaning you're going to have one fraction and then 0 on that side, one fraction on the left side and 0 on the right side. For example, if you have something like x plus 3 over x minus 2 less or equal to 0, that's the general or standard form. How do we solve such inequalities? Again, I have a handout in the notes. Let's write the inequality in standard form. One side must be one fraction and the other side must have 0. So just like that, this is all in standard form. Then find the critical values by setting the numerator and the denominator equal 0 and solve. So to find the critical values, you set the numerator equal 0 and the denominator equals 0. So you get x equal negative 3, x equals 2. Use the critical values to divide the number line into sections, just like we did in the quadratic case. 2, negative 3, so negative infinity to negative 3, negative 3 to 2, 2 to infinity. 1, 2, 3. Pick this value from each of the section and plug that into the test value, just like before, and then use interval notation. What you have to watch out for, though, that you didn't care about when it was quadratic, is the brackets and parentheses. Okay, you can see here I put brackets at 3 and I put parentheses 2, and there's a reason. That wasn't a mistake. Usually in quadratic, when we have less or equal or greater or equal, you're gonna put brackets. When you have less than or greater than, you're gonna put parentheses. With rational, like in this case, if you have less than or greater than, you're still gonna do parentheses. But if you have less or equal or greater or equal, use brackets, except where denominator of that fraction is 0. Why is that? Because if you look over here, x minus 2 equals 0 and x equals 2. If you put a 0 there, any number divided by 0 is undefined. That's why I put parentheses at 2 and brackets at negative 3. Okay? So you're going to still put brackets when it's less or equal or greater or equal at every critical value except the one that you get from where? From the denominator. Those will always have parentheses. If it's less than or greater than, it's parentheses for everything. So keep that in mind. So now we're going to do the test value. We're going to pick 0 and we're going to assume alternating unless we have 3 over negative 2, which is true. So this is true, false, false. So negative 3 and all the way to 2. Not including 2 though, is the solution. Let's look at 28, page 884. 28, page 884, x squared plus x minus 6 over x minus 4 is greater or equal to 0. Okay, so we have standard form because we have a single fraction and a 0. To find the critical values, we set the top equals 0 and the bottom equals 0. This is locally factorable, x plus 3, x minus 2. So x equals negative 3 and x equals 2. This is another critical value. So we have 3 critical values, meaning 4 intervals. Okay, it's always one more interval than the number of critical values. 2, 4, negative 3. So negative infinity to negative 3. Remember, it's greater or equal, so it's going to be brackets, except where the denominator equals 0. Okay, so at negative 3 we're going to have a bracket. At 2 we're going to have a bracket, but at 4 we're going to have parentheses. 1, 2, 3, 4, and they will alternate because each one of these show up an odd number of times. I'm going to pick 0 and plug it in there. 0 plus 0 minus 6 over 0 minus 4. 6 over 4 is greater or equal to 0. This is true, false, false, true. So negative 3, 2, union 4, infinity is solution set. Okay, there's one example on page 51. It's a good idea to do it next. That's yours to do, and the solution is there, so you can check your work. The next one I want to do is 34 from page 885. Negative 5 over x minus 4 is less than 3 over x plus 1. The problem with this one is it doesn't have a single fraction. It has 2 fractions, and I don't have a 0 here. So I'm going to make a 0 on this side by subtracting over x plus 1. So I have negative 5 over x minus 4 minus 3 over x plus 1 is less than 0. Now I got 0 over here, but I have 2 fractions, so I want to find the LCD, which is x minus 4, x plus 1. So I'm going to times this guy by x plus 1. Top and bottom, this guy by x minus 4 to have the same denominator, so I can work it out. So this would be negative 5x minus 5, distribute the negative 3 minus 3x plus 12 all over x minus 4 x plus 1. So that's negative 8x plus 7, because negative 5 plus 12 is 7 over this guy, and now we got the standard form. So now we set the denominator and the numerator equals 0. So negative 8x plus 7 equals 0. X minus 4, x plus 1 equals 0. Find what we call critical values. So negative 8x equals negative 7. And one critical value is 7/8. Another one is 4. And a third one is negative 1. So if we plot these numbers, that's 1, 2, 3, 4, and 7. Oh, sorry. Oh boy, negative 1. So this is, let's make this 7/8. This is 1, and then negative 1. Okay. And it's all gonna be parentheses, right? Because it's less than negative infinity to negative 1, negative 1 to 7/8, 7/8 to 4, and 4 to infinity. 1, 2, 3, 4. I'm going to pick 0 and plug it into the original one. So 5/4 is less than 3. Obviously it's true. That's false, false, true. So negative 1, 7/8 union 4 infinity is my solution set. And there's one that I want you to do, add notes, so do it, and I'm done with 10.5, and all of chapter 10 is done.